this video, I'm going to show you the steps to install a new 48 volts lithium iron phosphate battery in the Ryobi RM480E, and how to charge it with solar power if you're interested in that. However, the steps are very similar for the zero-turn version of this mower, so if you have that mower, this video should still be helpful. I've been working on the 48 volt Ryobi lawnmower series for some years now, and I really like them. So here's my Ryobi RM480E. I got this for doing chores around my 35-acre homestead. I got it broken and I had to do several repairs to it. One of the problems is the lead-acid batteries it comes with are just not up to the task. And it's not very long after I got this lawn tractor that the lead-acid batteries started to fail. I really need this machine to be reliable, and that means getting rid of lead-acid batteries. And I refuse to put 4 12-volt batteries in series. That's just not a good idea. I've always used 48-volt battery packs for my mowers. So I went with this Allpond 48-volt 100-amp-hour LiFePO4 battery. Full disclosure, they sent the battery to me, but I don't collect any affiliate commissions. I'm not too sure how reliable it's going to be, but it's better than 4 12 volts in series, so let's give it a try. This battery retails for $1,300, so it's not cheap. But if you subtract the price of a new lead-acid battery set every year, which is what it's going to take, it will pay for itself, in theory, in about 4 years. The charger's rated at 18 amps, although I only ever saw about 16 amps into the battery, so I guess they're counting the full wattage, including the AC side. It comes with mounting hardware, battery post bolts, and also some ratchet straps. That's to hold the battery down to the vehicle. I will show the display later. Well, before I give this battery a true test, I need to find a way to install it in my Ryobi tractor, so let's do that first. Now, to make things a bit easier, I recommend that you remove the back panel of the mower, and then there's a top panel, and if you take the screws out that are holding it, what you can do is bend the tabs back a little bit and pop them out from under the side panels, and that way you don't have to take the side panels off. Rather than trying to slide the old batteries out the back, I recommend you remove the top so you can see what you're doing. You will have to remove the seat in order to get the top panel off. Disconnect the charge controller circuit using the plug. You will need to disconnect this plug as well, which feeds from the charging circuit into the battery. Next step is to simply remove the hold-down bracket by removing the long bolt that is going from the top to the bottom. Be sure to disconnect the seat switch as well before you remove the seat. That's this plug here coming out from underneath, and it goes to this cable here. Now I need to remove the cover plates off of the top of the batteries as well as the hold-down bracket itself. Remove the charging plug and the control plug as well. This will free up the entire charging port assembly with the charge controller, and you can set that aside. Now I'm going to remove the plastic cover plates, taking care not to damage the temperature sensor here, which is required for the mower's OEM charging circuit to function properly. Now I will disconnect the main 48 volt power plug. Now you can easily remove all of the connections for the old batteries. There are 8 total. If you use a crescent wrench or a ratchet set to undo the bolts, you should tape the metal handle to prevent an accidental short circuit. On these mowers, the battery tray can slide out, so you have to remove 2 bolts, and they're pretty tight. There's more than one way to get these batteries out. I'm personally a fan of removing them one at a time rather than sliding out the entire battery tray all at once. The manual shows the entire battery tray being slid out and supported by something, and you can certainly do that. If you have a scissor jack or something like that that you can lean it on, that would be fine. But I'm just going to remove one battery at a time, as that's always how I've done it. In order to get the batteries out more easily, I'm going to remove this clamp or spacer that's in the rear. And now I can pull out the hold down bracket off of the top. Next I remove the main 48 volt power plug, which is on the main positive and negative terminal of the battery pack. Here I opted to slide the tray out part way to help me get the last couple of batteries out. And now finally the last lead acid battery is removed from the machine. You can loosen this tray, and you can go ahead and use that to help you get the batteries out. You can do that as well. Just be very careful to support the tray as you begin sliding it out, because there's nothing at this end that's going to hold it up. It's going to go like that. So you want to be very careful and hold this end of the tray up while you're doing that. Now there's several ways to mount a new battery pack in this frame. If you're going to be using a single large 48 volt battery, you're going to want to remove these steel spacers that are located in the center of the removable battery tray. Once you have the batteries out, this is a great opportunity to clean out the inside of the mower and remove all the dust, dirt, and grass clippings. In some cases, I use a piece of wood to make a platform below the battery, and you can use this with the battery tray, or you can use it to replace the battery tray. I actually prefer the piece of wood because it prevents a lot of the grass clippings and dust from coming up underneath the mower, but it's really personal preference. In this case, I just cut myself a piece of particle board from the scrap that I found laying in the barn. For right now, I did not use the particle board, and I just placed the battery directly on top of the original battery tray. I'll use the piece of wood in a future project with this mower, so stay tuned. The installation of this battery is pretty simple. Just put it on the tray and slide it in. Push it all the way forward so that it seats itself against the front battery clamp. I'm now using the ratchet straps that were provided to strap the battery down to the tray and to the chassis of the mower, taking care not to run the straps anywhere that would interfere with the mechanisms for the mower deck or any other part of the mower. If you use ratchet straps to hold the battery down, make sure and look underneath the mower and ensure that they're not interfering with anything underneath. I also added a piece of scrap foam from the packaging in between the ratchet handle and the case of the battery, just to keep the two apart. Now I'm reinstalling the two hold-down bolts for the battery tray, as well as the two spacers that go in between the battery tray and the chassis of the mower itself. The manufacturer includes two lengths of bolts for the positive and negative terminals of the battery. In this case, I used the two shortest ones. Time to hook up the battery. Now I'm reattaching the main power plug to the positive and negative terminals of the new battery. By the way, the main power plug for the mower is referred to as an Anderson connector. If you use an impact driver to tighten the battery bolts, be careful as it's very easy to strip the battery post out. If you have a charging plug provided by the battery manufacturer, you would also need to put that on these terminals as well. I plugged it in for the first time after reconnecting all of the other connections temporarily and turned the key. The mower powers on. Okay, I just did a quick test on this mower to make sure everything is wired up correctly and that it's working. It does appear to work very well. So now it's time to do some real testing. Now, if you do it just right, you can put the top panel back on without removing the side panels. So I'm going to go ahead and try to do that now. All tabs can be carefully tucked under the side panel edges by bending them. Just don't bend them too much. Check the screw holes to make sure that they're aligned properly so you can reinsert the fasteners. I do not recommend using an impact driver to reinstall these fasteners because most of them are just metal clips located in plastic and it's extremely easy to break them off. I removed my charging port during the process of working on this mower, so I will reinstall it here now. And now the rear panel can finally be reinstalled. And finally reinstall the seat by fastening it with two bolts. And don't forget to reattach the seat switch. One of the interesting things about this battery is it comes with a display which is able to talk to the battery management systems and display the battery status information in real time. The battery has a connector on the front that looks something like an XLR plug, and you can plug the display right into it. I will be charging this mower with solar power, but I wanted to try out the charger that it comes with. The charger has an aluminum die-cast housing and a fan to cool it. The charger appears to run about 1 kilowatt, which is pretty decent. We're getting about 16 amps into the battery. By my calculations, the mower battery is getting about 880 watts of charge, and the electrical efficiency is something like 90%. Okay, I like the display. It covers all the bases. It shows every single cell and the voltage. That's very important when you have 16 of them in series. It shows you how many amps you're pulling. I would like to see a wattage or kilowatt readout, but that's okay. I can calculate that in my head. It's basically a Coulomb counting amp meter or battery fuel gauge, and that's exactly what you need for a vehicle or a mowing application. But what would a battery test be without a mowing test? This mower deck has two brushless motors, BLDC, and it draws something like 30 amps just to run those motors and clip a little bit of grass. In the rear of this machine is a very large BLDC motor that draws about 250 to 500 watts just to move this machine forward. Once you start adding weight and a trailer, it gets higher than that. I found the display to be very difficult to read in the sunlight. It's probably meant to be under a roof of a golf cart, but at least I could barely see the percentage readout while I was mowing, and that's good enough. So after well over an hour of mowing, I found that the battery was only down to 71%, which is astounding because the lead-acid batteries would have long quit by now. At this point I haven't encountered any problem and the cell balances look great. So far so good. I'm actually rather impressed how long I was able to run this mower and still have plenty of power left over. Grass mowing may not seem that exciting, but when you consider the amount of gasoline that's burned, it's very exciting not to use one drop. Basically, I cannot afford a tractor, so this little thing here is my tractor, and I use it for hauling all sorts of random odd loads all around the homestead, and I can charge this with a tiny 100-watt solar panel, and I'll show you how to do that in just a minute. And towing the trailer is not the same as mowing. It doesn't use as much power. I can run this mower for hours and hours and hours all over this 35 plus acres and still not run the battery down. And never touch a drop of gas. This is a basic, budget, trickle charging setup for a Ryobi lawnmower. It can charge a 48-volt battery from a 12-volt solar panel. It didn't cost a huge amount of money. The solar panel, it might be about $50 to $75. And of course, you have a circuit breaker, another $10, and maybe some wires and cables. So really not that expensive. And this is how you can break free from gasoline and start using electric mowers, try out some solar charging. And remember, these mowers come with a charger that plugs into grid power or into an inverter. So if you need to charge really fast, you can still use that charger, plug it into the back, and use that in an emergency to charge your mower more quickly. And you can still take advantage of solar power while you learn the ropes. It takes time to learn all this stuff, so don't rush it. If you build a small system kind of like this, then you'll learn by doing, and that's what DIY is, learning by doing. There's a cost versus benefit. So if you want to charge fast, it costs more money. If you're willing to charge slower, then you can spend less money, and you can use a smaller system. I have several setups, but this is one of my favorites. It's very small. You can see there's a cable connected into the back of this RM480E, and that's running at 48 volts nominal voltage. And that cable comes all the way down here, goes across the ground and into my shed. This is quite old. I've had this for a number of years, and I used it a lot to charge this machine. This is my other 48 volt Ryobi lawnmower. And I've had this a number of years. I think I was the first one to convert one of these to lithium iron phosphate. I didn't put it on YouTube, but it was quite a few years ago. But this machine here, believe me, has had a lot of solar charging coming in through this very setup right here. So what we have is we have a small 100 watt solar panel outside, and that is feeding in through this wire here. Very simple, very basic stuff. So the panel I'm testing today is this 100 watt flexible solar panel, and I just have it temporarily clamped on the roof so I can have a look at it and test it. So far it's doing quite well. I'm not a huge fan of the junction boxes on these flexible panels, but anyway, I'm giving the solar panel a try, and we have MC4 connectors feeding through the wall of the shed. There's the wires going up inside the shed, and that's coming out the other end where the charge controller is. And that's these wires here. So you take your solar panel, positive and negative, and you run it into your PV breaker, positive and negative. In this case, it does have a positive and negative. Not all breakers are marked that way. This is a double pole breaker. You got to make sure and keep track of your positive and negative. So the positive and negative actually comes out and, funny enough, feeds into a fuse block. So I'm really careful. I have a lot of reasons for doing this. I do a lot of direct PV powered applications, and that's the reason why I have a fuse block in between, because I'm going to be connecting other things to this panel. Anyway, there's a lot of wires here, but I have a voltmeter to read my PV input, solar input. Point is that the positive and negative comes down here to this MPT7210A. I have a whole video dedicated just to this charge controller right here. It's kind of interesting, it's a gem, and it can charge these 48 volt lawnmowers pretty easily if you know how to set it up. It is a manual set MPPT charge controller, meaning you have to set your own VMP voltage and you have complete control over all the parameters in the machine. So I really like that. The positive and negative of this charge controller on the solar side is connected right here, and that's the same wires you saw coming in the shed through the breaker. Then we have the part that goes to the mower. So the mower is going to be a 48 volt battery, and you need to raise the voltage of the solar panel up high enough so that it will charge a 48 volt battery. So that means being around 53, 54, 55 volts is what's going to be necessary. At this point, we have the wires coming out and they're going into a fuse, because I never ever connect my mowers to any charge controller like this without having a fuse. Not a circuit breaker, a fuse. And in this case, it's just a couple of amps because I'm only charging at 50 to 100 watts here, so I want a small fuse. I really don't push this charger very hard. I don't need to, it's a trickle charge and I'm satisfied with that. I might go for 200 watts later, we'll see, but a 100 watt panel for me is doing the job just fine. So when you come out of your fuse, you want to use a cable. I'm using standard DC cable because I'm not pushing a lot of power, it's rather thin. I would recommend using a good quality cable that's at least 12 gauge or 14 gauge. Even 10 gauge would be nice. And make sure that it's brightly colored so you don't trip over it. When you're charging a mower, it's a little bit different. The cable could be tripped over, you could drive the machine away, and you could yank the cable out, so you've got to use a fuse. The fuse needs to be something that blows, and that's it. It's off, and it won't come back on by itself. You can't have someone just come over and flip a switch and turn it back on. You would have to replace the fuse. And that's for safety. So the other thing is you got to set the charge controller, which must be 48 volt compatible, to the proper voltage for your batteries. Most people use the OEM or factory recommended defaults. I do not. But the fact remains, this type of charge controller lets you put in whatever voltage you want and you charge your mower. It's that simple. Then of course you need some kind of a plug to plug into the mower itself, and you can use any kind of plug you want. When you're only pushing 50 to 100 watts, you have a lot of leeway. You can use like an IEC connector, just wire it up in there and have an IEC connector connected to the positive and negative of the battery. You can use the OEM charge plug, which is right over there. I currently haven't done that, but I plan to in the future. The most important thing when you're setting up your plug and your wires, use a multimeter and get the polarity correct. You only get one chance. Don't hook it up backwards, you might burn something out. This is a digital multimeter, just a simple basic model, and I have a great video about how to use this. It'll take you from basic skills to intermediate and even some advanced topics. A multimeter like this is mandatory for hooking up a cable to your mower because you want to do it safely. You can use this to verify polarity of a battery, verify there's voltage, what the voltage is. It's just indispensable. You can't afford to do any kind of electrical DIY without at least learning the basics of a multimeter. I'll link that video in the description. Most charge controllers these days lower the voltage down to the battery. But in this case, I'm raising it up to 40 to 50 volts to charge my lawnmower. So it's important to make sure that if you're using a single 100 watt panel, look for a charger that can boost the voltage. It's called a boost solar charge controller. I'll put some links in the description to the various parts that you might want to use for your system. And there's a few options, not just this one here, for boost controllers. But I really like this one here, and that's why I made a really long detailed video on setting up all those settings and getting it set up just right. Here I'm using the Allpond 48-volt battery, and you can see I'm charging at a current rate of 1 amp. It will sometimes cut out because the charge controller may reset, or the shunt in this battery isn't sensitive enough to detect it. I'm not worried about the slow charge. It can take all the time that it wants, and that's fine with me. If I need faster charging, I'll just have to use a bigger setup, that's all. I actually love modifying these 48-volt Ryobi mowers, and in part 2 I'm going to do some additional modifications to this mower. It's good that it has such a large battery in it. You'll see in the next video why that is. So please be sure to subscribe and stay tuned for the next video in this series. Folks, I hope you liked this video. If you did, please leave it a thumbs up, subscribe, and leave me a comment if you have time. Thanks for watching, and I hope to see you next time.